So in this next lesson, what we want to do is we want to convert whole equations now, not just individual points. But we're going to use the same things that helped us before. R equals x cosine theta. R equals, or sorry, I got that backwards. Hang on, I'll fix it. Every once in a while I do that. X equals r cosine theta and y equals r sine theta. And then if we're converting from rectangular back to polar, then we used r equals the square root of x squared plus y squared, or this could be r squared equals x squared plus y squared. And then we use theta is equal to the inverse tangent of y over x. And so we're going to use these same things to convert equations. So let's get right to a couple of examples. So here we have a polar equation and we want to convert it. So r, we know, is the square root of x squared plus y squared. Plus, so we make that substitution, plus 3 times the sine of the inverse tangent of y over x. And that's equal to 3. So we have now converted it to rectangular, but what we'd like to do is get rid of the sine inverse tangent. So this goes back to our chapter 1 and some of our chapter 3 problems that we did where we had to use the triangle on the inverse tangent. So if I draw this triangle here, this is y, this is x, all right? And the hypotenuse is the square root of x squared plus y squared, all right? Using the Pythagorean theorem, x squared plus y squared equals hypotenuse squared. So h equals the square root of x squared plus y squared. All right, I don't want to make it r because I want to keep it in terms of x and y. So then the sine of this angle being the inverse tangent of y over x, theta, the sine of that angle is the opposite over the hypotenuse. So this equation now becomes square root of x squared plus y squared plus 3, and then the opposite is y over the square root of x squared plus y squared equals 3. And so now here's our equation, okay? Also correct. All of these are correct. Now we want to move a little further to simplify this because we don't like radicals in the denominator. So we would multiply everything by the square root of x squared plus y squared to over square root of x squared. Is that right? No, we would just multiply the, we would just multiply this part by this to rationalize the denominator. And what we would end up with is square root of x squared plus y squared plus 3y times square root of x squared plus y squared over x squared plus y squared equals 3. Now, this is not necessarily any simpler than the one above it, but essentially we have now converted it to rectangular coordinates. Now, what I want you to notice is look how simple the polar equation looks, and then look how complicated the rectangular equation looks. This happens both ways. Sometimes the polar equation's ungainly complicated, and the rectangular equation's pretty simple. But the reverses can also be true, and that's what's happening here. All right? I would probably accept either of those answers as a final answer. Okay? All righty, let's go on to another example. So here's another example of a conversion. So right away we can do what we've done already. We can say r equals the square root of x squared plus y squared equals 6 cosine of 3 times the inverse tangent of y over x. Okay, now this is 3 theta, all right? And we want to get rid of the cosine tangent because those are circular, and we have a 3 theta here, 3 times an angle. Now, we've never learned the formula for 3 times an angle, but we're going to learn it right now and how to rewrite this. What you first do is you divide this up into cosine of 2 times the angle plus 1 times the angle. If you do that, then you can rewrite this in a form of alpha plus beta. So this whole right side becomes 6 cosine of 2 inverse tangent of y over x, cosine inverse tangent of y over x minus sine of 2 inverse tangent of y over x sine of inverse tangent of y over x. Okay? Funny, this looks like a test question, doesn't it? So then you'd have 6 times everything. This is now a double angle. Those are double angles, so you got to rewrite those. So then we go cosine squared inverse tangent of y over x. All right, minus sine squared of inverse tangent of y over x times this part here gets multiplied by the cosine of inverse tangent of y over x. All right? And then from that, we subtract. We have sine of 2 alpha, so that'll be 2 sine of inverse tangent of y over x, cosine inverse tangent of y over x, times sine of inverse tangent of y over x. All right? Woo! What a long, nasty booger this is, right? So let's move this up a little bit. Let's take a look at this. If you look here, you get a cosine times a cosine, which is cosine cubed. So we'll have a cosine cubed of the inverse tangent of y over x, okay? And then you get minus a sine squared cosine. So minus sine squared inverse tangent of y over x, cosine inverse tangent of y over x. All right, and then you get, and this is all minus, so then we have a minus. And you got 2 sine cosine times sine. So that'll be minus 2 sine squared inverse tangent of y over x, cosine of inverse tangent of y over x. And as you can see, even though this is really ugly, there are 2 like terms here. I got a minus 1 of this and a minus down here, and those combine to make it minus 3. So the problem actually simplifies to 2 cosine cubed inverse tangent of y over x minus 3 sine squared inverse tangent of y over x cosine of inverse tangent of y over x. Now, the reality is all I have to do is figure out what the cosine of the inverse tangent and the sine of the inverse tangent are. And both of those are easy. I can draw the triangle. This is y, this is x, this is square root of x squared plus y squared. So the cosine is x over that. So I'm going to get equals 6 times x over the square root of x squared plus y squared cubed, because I got the cubed on the cosine, minus 3, and the sine squared is y over that. So I'll have y over square root of x squared plus y squared squared times the cosine of that, which is x over square root of x squared plus y squared, right here. And we are almost done. If you wish, well, no, we can just leave it. We can put the 6 here. And I think that 6 would have been times everything. So I got to remember that 6. I kind of forgot that it was multiplied times everything. So this will actually be 18. So pardon me, I'm sorry about that. So we get 6x cubed over x squared plus y squared to the 3/2 power minus 18 xy squared over x squared plus y squared to the 3/2 power. And if you go just a little further to simplify it, you could say it's 6x cubed minus 18xy squared times 1 over x squared plus y squared to the 3/2 power. And that's actually pretty simplified, if you think about it, from what we started with. Now, not all the problems you have to do are going to be that ugly. But as you can see, you really have to pay attention to the algebra all the way through the problem. Okay? But in general, that's how you do these problems. You make those substitutions, you work them out. You want to do one more? Let's do one more. Okay, here we go. In this case, we have r squared, so we right away know that is x squared plus y squared minus 4. Sorry, it's r squared equals, so it's equal to 4 sine of 2 inverse tangent of y over x. Now again, that's a double angle. So sine of a double angle, we want to rewrite that. So x squared plus y squared equals 4 times 2 sine of the angle, inverse tangent of y over x, times the cosine of the angle, inverse tangent of y over x. And so the 4 times 2, that gives us x squared plus y squared equals 8. And then we already found on the previous slide that the sine of the inverse tangent of y over x is equal to y over x squared plus square root of x squared plus y squared. And the cosine of that is equal to x over the square root of x squared plus y squared. So this equation is x squared plus y squared equals 8xy over x squared plus y squared. And if you wish, you could cross multiply and go x squared plus y squared equals 8xy. So this is a much simpler one to do, and I pray that your assignment doesn't have any like the last one, but has more like this, that where you do the algebra, but you don't get lost in the algebra. But I just want you to also notice how you have to know identities, how identities pop up all the time. Let's do one more going the other way. So now we want to convert equations, okay? So we want to take a rectangular equation and convert it to a polar equation. So let's do something simple first. Let's do like x squared plus y squared equals 4. So this is a circle of radius 2. In fact, since we know r squared equals x squared plus y squared, if we make the substitution here, we get r squared equals 4, or r equals 2. Circle of radius 2. Anyway, that's a pretty simple conversion, right? It's the kind of thing that we want to remember. Now, the other way you could have converted this is you could have said, oh, x is equal to r cosine theta squared, okay? Y is equal to r sine theta squared equal to 4, okay? And so now this is r squared cosine squared theta plus r squared sine squared theta equals 4. And you can factor the r squared, and you get cosine squared theta plus sine squared theta equals 4. And cosine squared plus sine squared is 1, so you get r squared times 1 equals 4, which gives us r squared equals 4, or r equals 2. So you could have made either substitution and solved for the polar form quite easily. All right, let's do one more of these. Now, one of the things we did last semester was we did like ellipses and hyperbolas and parabolas. So let's kind of see what the polar form of these might look like, all right, which could be kind of fun. So let's pick a parabola. Whoops, and my camera popped on, so, okay, fixed it. It's just called fat fingers hitting buttons, all righty. Anyway, let's pick a parabola, something that's not too difficult. Let's go with like x squared plus 2x minus or plus 1 equals 0. So here's an equation, and we want to convert it to polar form, all right? And so the x's I can change to r cosine squared theta, all right, or excuse me, r cosine theta squared, there we go, plus then 2 times r cosine theta plus 1 equals 0. So then we get r squared cosine squared theta plus 2r cosine theta plus 1 equals 0. All right? And this is now in polar form. Okay? And so it's fairly straightforward. If I'd have said it was equal to y, then I would have put r sine theta over here, right? But that would be the equation in polar form. And so then you can choose to say, well, can I change that r sine theta to a cosine, make it all in cosine? You could, but in general, this would be perfectly okay. Alrighty? Thank you. Good luck on this part of the assignment. Let me check and see if there's anything else. Yeah, I would probably say my suggestion is make sure you do the practice. Make sure you do practice. Their problems are much simpler than the ones I grabbed. I just grabbed mine out of a textbook, and they happen to be, some of them, pretty hard. But make sure you do practice so you kind of recognize the things they want you to, especially as you head towards the quiz. So we'll take the quiz on the Monday we come back from spring break. I'll make a video over spring break and it'll be ready for you. Good luck. We shall see you. Have a great holiday. Catch up if you're behind. Bye bye.